So we're going to start today, like I said, solving and graphing what are called quadratic functions. Sounds like a really complex thing, but it's not really. Instead, when we go to graph, we're used to things being in y equals, okay, and they still are. Except now, we're going to start getting x squared in there instead of x. And that's really not going to cause us a lot of trouble. The only thing that we've got to keep track of are these values in front. And they go just like the alphabet, A, B, C. So when we're looking at numbers in these, as long as it's in y equals, we'll be in pretty good shape. So these quadratic functions make these U shapes that are called a parabola. And that's just a fancy name for it. But the stress here is that they're U-shaped. So as we're doing those, that's what I'm going to be calling them. So if the lead coefficient, or if the first number that you see right in front of x squared is positive, my parabola opens up. It'll look something like this. Might be a little skinnier, might be a little fatter, depending on what the number is in front, but it's always going to look that way. So before I even punch it in the calculator or graph it, I can always know what it's going to look like. If that number in front of x squared is negative, the parabola opens down. So it'll look kind of like a frowny face, okay, or like a hill. So we always are going to know that. Even if we don't know anything else, that'll be a question that'll show up on worksheets and quizzes and things like that. Should be an easy one to kind of catch on, especially since this is notes and you'll have these available to you. Sure. And so as we're doing these, okay, there's also parts of the parabola that we can start to notice. And one of them is called the vertex. Now the vertex is either the lowest point of a parabola that opens up, or it's going to be the highest point of one that opens down. And this is one of those times I like to just draw a quick picture off here to the side. So if I have one that opens up, this point on the very bottom, it's almost taking like a smiley face and having a tongue stick out here, okay, would be my vertex. Or if it opens downward, the point on the very top would also be my vertex. And we can figure out what point that is. And we're going to talk about how to find that specifically here in a little bit. But we're just working with a little bit of the language here at the start. So then, one cool thing about a parabola is, if you take it, and I'll do this one, the first one we do it, you took it and you folded it in half, it'd be exactly the same on both sides. It's symmetrical. So the line that I'd be able to fold it on to make that happen is called the Axis of Symmetry, or the AOS. And that's going to be real easy to find too. We're just going to steal one value every time. But one thing I want to make note of here is that my axis of symmetry is always going to be an x equals equation. It's never going to change. And when we get into some of those here in just a minute, did I just put that as the axis of symmetry? Symmetry. Wow. Okay, so, but again, and I know it's a lot to keep track of right now, but we'll kind of get you into a mode here in a minute. And then the solutions, or the answers, we're going to call them roots. That's what we're going to call them most of the time. But depending on what you're looking at, on books, on standardized testing, they use different names. Roots is one. Sometimes they may use the word zeros. Okay? Or they may even just call them the x-intercepts, because that's where we find them. Those words are all interchangeable with this, and I wish they'd have just chosen one word. That would have made this a lot easier, but they didn't. So we'll have this available to us in case they put a word in there and we're not sure what it is sometime. Yeah?
What does number 5 say?
Number 5 is the vertex, V-E-R-T-E-X. Okay? So, whether I have a graphing calculator or not, okay, down here at the bottom of our sheet is basically how I would go ahead and find my vertex and get ready to graph it anytime. So I always make sure it's in y equals. I always write down what my A, my B, and my C value is. And then the vertex, this is the key on this whole part. I'm going to get this x value, and it's always negative b over 2a. And you'll find out later that's part of another formula called the quadratic formula that I can use to solve equations if I don't have a picture to look at. But we'll do some of this to get some practice. And then my vertical line, my axis of symmetry, is always just that x value. Okay? So, to actually get into one of these, so we can kind of make sense, and we'll flip back and forth when we're doing these. Okay, here at the start, we're not going to worry about graphing. We're just going to concentrate on finding the vertex and the axis of symmetry, getting used to the equation a little bit. So when I have an equation, my a value is always going to be the number that's in front of x squared. It's going to be the first number that I see. B is always going to be the second number, or the number in front of x. And if there's a c value, it'll just be the value on the end. Okay? Now, if I have one missing sometime, that'll just be 0. And we'll get a couple of those too. So when I get to here, you're like, well, now what? Well, I'm supposed to find the vertex. So my x value, and I'm just going to write it up here at the top so we can see it every time. To find the x value, I always plug it into this negative b over 2a equation. And this is going to be no different. So I go to plug this in. I'm like, okay, so negative 4 over 2 times my a value, which is negative 2. And I just got to figure out what that is, and I'll have my vertex, okay, the x value. So 2 times negative 2 is negative 4, and negative times negative is positive. So in my vertex, the x value is going to be 1. Once I have that, and again, that'll be the same every time, then I go in and I look for my y value. Now, there's not a fancy formula for y. To find y, I'm just going to substitute the x value into the equation. So I've got negative 2, and whenever I plug in my x value into the equation, I'm going to put it in parentheses. So then plus 4 times, and I see another x there, so I'll plug my x value, my 1 in. So basically what I just did was I copied this, but wherever I saw x, I plugged the x value in. So now I've got to figure this out. Now, if you don't want to go through having to deal with all of this, and you want to go and use a calculator, you absolutely can. So what we'll do here is we'll take a moment, put in our little thing for having one of these to play with. And you could do this on any calculator. It doesn't have to be the fancy ones that we have in here. So what I'm going to do is basically I'm going to take this and I'm just going to type it in. So negative 2, my 1 in parentheses, and my squared button's over here to the left, kind of in the middle. I know it says x squared, but it doesn't put an x, it just does the squared. And if you can do this in your head, that's fine. I just like this because it'll take care of everything for me. So that equals negative 7, which would be the y value of my vertex. So if I were graphing this, this point would be that little point that's right in the middle, where it changes directions. And my axis of symmetry, this is the easy part. X equals whatever the x value is in my vertex, is what goes here. My axis of symmetry is 1. And we'll visually see that in a bit. But I just want to do some of the math portion of it first before we jump into all the graphing business. But if you can get those two things, this is easy, okay? And this is actually the longest part of it. Now b, we got to be careful. What number's in front of x squared? 1. What number's in front of x? 0. There is no x here, okay? Since there's no x, just an x squared, my b value is 0. I can't just write them in as I go along.
So you just assume it's a 0?
Yeah, if I don't see an x anywhere, I assume that's going to be a 0.
Why can't you put a 0 at number c?
Good question, because when we're doing these, I'm going to flip back over for just a second. The form that we're using is this one. So a is always going to be my number in front of x squared. B is always going to be my number that's in front of plain old x, and if there's just a number by itself, that's always going to be my c. So on this one, since there's no x, that's why I have to use the 0 for b instead of c. Good question. So now I can do my thing. X equals negative b over 2 times a. And I'll even show you when we get to the graphing, there might be a way to get around this. We'll see. What's 0 divided by anything going to be? 0. Okay, so my vertex value for x is 0. And then for my y, again, I'm just copying what I see, but whenever I see an x, I'm going to replace it with 0. Yeah, and we know 0 squared is 0, so that minus 10 is negative 10, which would be the y value of my vertex. And then my axis of symmetry is just x equals and my x value, and I'm done. So it's nothing that ends up being anything too bad as far as this stuff goes. So let's do one more like this, and then we'll actually get into graphing it here. We can actually start seeing why all this is important. So let's come down and do C. So we're like, okay. So what's my A value for letter C? 1, because it's whatever number's in front of x squared, and I see an x squared, so we're going to have 1. Okay. What about B? 4. And then C is my only number that's left by itself, the negative 1. And again, I'm just going to use that negative b over 2 times my A value. And my A value can change. We've seen that up in A. So let's see, negative 4 over 2. What's that going to equal? Negative 2, which is then the x value of my vertex. And then again, just to remind you again, and I know we wrote it on the front, but I'll just mention it again here. Whenever you're substituting values in for x, make sure you do it in parentheses, because otherwise your answer will be different. So everywhere I see an x, I'm going to replace it with my x value, negative 2. And again, I can either do that myself, or if I want, I could plug it into a calculator, but again, I got to have the parentheses or my answer is going to be different. So it's the little detail stuff that might get you on these if you're not careful. So my y value is negative 5. And my axis of symmetry is just the x value from my vertex. Okay. Once you get that vertex especially, the rest of this just works itself beautifully. It's the nice thing about having something that's symmetrical. So, when we actually get to the graphing part, which is what we're going to do here momentarily, we're going to do what we just did up above. We're going to plot the vertex and the axis of symmetry on a graph, and then we're going to make a table of values, but it's all going to center around the vertex, and we'll see how that works in a minute here. And then we're just going to connect, and we're going to make this U shape. So here's how this is going to go. All right, let's see how this works. So we start with an equation again. Okay, what's my A value in this one? 1, because that's my number in front of x squared. What about B? 0, because again, there's no x this time. And C is just my number on the end. So we're doing exactly what we just did in the last group of examples. To find my x, I do negative b over 2a, But we know 0 divided by anything is going to be 0. Okay, so we've got that part. So then I go, okay, well, what else do I have to work with here? Let's see. I need to find my y. And again, any place I see x, I'm going to plug in 0. Still going to use parentheses. So I'm just plugging it back into the original equation. 0 minus 1 is negative 1. So that's my vertex.
I know we can do it in the last one.
So the vertex is at 0, negative 1. So I'm just going to plot my point there. My AOS, my axis of symmetry, is x equals 0. Now, you won't see until we actually plot all the points, but the axis of symmetry normally is just a dotted line that we put in along that point. So if it's at x equals 0, I just go to where x is 0, and I just make a vertical line. Always going to be vertical or up and down. Don't worry about the roots yet. We'll get to that. And we'll do the opens part once we do the graph. So here's how this is going to work. We got this chart. My vertex always goes in the middle. So once I find the vertex, that's the center of my chart. And to find the other values, I just start adding 1 as I go to the right. So 0 plus 1 is 1, plus another 1 is 2. And I subtract 1 each time as I go to the left. So my table can change depending on what my vertex is. But here's the cool thing. I don't have to plug every single one of these into here to find the values, because this is symmetrical. And what that means is these two are going to end up being the same, and these two are going to end up being the same, which means if I do one of them, I'm doing the other. So here's what I'm going to do. To find my, let's say I decide I'm going to do 2. I'm going to plug that in here. So this would be y equals 2 squared minus 1. So 2 squared is 4, minus 1 is 3. Whatever answer I get for positive 2, in this case, will be the exact same answer I would get if I plugged in for negative 2. Because negative 2 squared would be 4, minus 1 is 3. So if you're looking for a shortcut so you don't have to do as much work, that's something you can do. And then I can pick either one of these to plug in. I like positive numbers, so I'm going to do 1. So it'd be y equals 1 squared minus 1. Well, 1 minus 1 is 0, which means both of these will be 0. Okay, it won't change. So now the only part I got left to do is to take the points that I have here, because these are just coordinate points, and plot my points. So left 1 and 0. I already got 0, negative 1. 1, 0, and 2, 3. And you'll notice my dots look like they're the same distance away from my dotted line there. Because what happens is I've got this curve, and if I were to fold it over that green dotted line, it'd be exactly the same on both sides. So that's how these work. You're like, well, what about those 2 blanks we got over there? You know, what's up with those right now? Well, what direction does my parabola open? Up. Well, why? You know, how do I know that ahead? If my a value is positive, I know it's going to open up. If my a value is negative, I know it's going to open down. So that opens up. And then roots, okay, there's 2 ways you can deal with a root. Either you can find the places where, oops, I'm off the screen. You can either find the places where y equals 0, or where it crosses the x-axis. And in this case, that's one of the spots. I've got two of them. I've got one at -1 and +1. Because I can see that y equals 0 at both of those spots. Or I can just look at my graph and say, oh, it's going through the graph here at -1. Oh, it's going through the graph at +1 for my x-intercepts, where it crosses the x-axis. So that's all the information that we can get from this. But it all centers around, can I get the vertex? Because if I get the vertex wrong, I'm kind of screwed as far as this goes. So, you're like, all right, I suppose we can look at one more of these. But before we look at another one, I want to show you something else. If some of you like doing the whole technology thing, here's another option you have. If I hit y equals on this, and I just type in the equation that's there. So I'd have x squared minus 1. Okay. And then I'd graph that. Just hit graph, just so I can see, okay, you know, that looks like the one that I have here. But, you know, if I just was sketching, that's okay, but how can I be accurate? We've done this before. Watch this. Second graph gets me the table. Huh. If I know my vertex, check this out. There's my vertex, 0, -1, which I found. And just look at the points above and below. -1, 0, 1, 0, just like I had in my chart. -2, 3, 2, 3, just like I have in my chart. The calculator can do the work for you, okay, if you're in here working on some of them. It didn't take us real long down here, but this is a nice backup option for you if you want to be able to do it that way, okay? So we'll just put a reminder in here. I think I'll put it up here at the top. So we can graph on the calculator, and then we can use, use second graph, which is my table function, to get the table, if you wanted to go that way when you're working on stuff in here, okay? And we'll kind of do it both ways on a couple more of these. But there are some certain things I just want you to be able to do, okay? Because you may not get something that works pretty for you every time. So this one, let's just find the vertex on this one, and then let's use the calculator and see if we can quicken this up a little. So what's my a value in letter B? What number's in front of x squared? Close? -1. Okay, what about B? 4. And C is -4. So this first step never is going to change. My vertex, my x equals, is always going to be -b over 2a. And I got to be careful here, because if I mess up a sign or something, that's going to just mess up everything for me. So take your time. What's a negative divided by a negative going to get me? Positive. All right, so my x value is 2. So then my y, let's see here. Now I got to be careful. The negative's there, and then the 2 goes to the squared here. The negative doesn't go in the parentheses with the 2 because it's sitting out front. So then plus 4 times my x value, which I'm going to put in parentheses, minus 4. So let's let the calculator help us a little bit here. I'm just going to type this in. So -2 squared plus 4 times 2 minus 4. Zippo. All right. So I've got my vertex. Now, since I've decided I want to do this on the graphing calculator this time to help me out a little bit, I already know my axis of symmetry is going to be at 2. So here's the couple of things I can do. 2, 0, got my vertex. I know my axis of symmetry is just a vertical line going through where my vertex is. Okay. So when I go to put this in now. And again, I can do this manually too. So I've got negative x squared plus 4x minus 4. Okay, make sure you get it in exactly the same way. I'm just going to take a look at the picture for a minute just to make sure it's looking okay. It opens down. That makes sense because it's negative. It's going through my vertex basically. This is looking good. So second table. Now if I did this right, okay, there's my 2, 0. I'm going to get that right in the middle, and I see, oh, negative 1, negative 1, negative 4, negative 4, negative 9, negative 9. If I have the right vertex, it's going to be symmetrical. You're going to have those numbers there. So when I go to make my chart now, I know my vertex always goes in the middle. And now I can basically just copy from what I see on the calculator. So 0 and 4, both are at negative 4. 3 and 1 are both at negative 1. And I know it opens down, so now if I move this out of the way for a second, I can plot my points. 0, negative 4, 1, negative 1. I already have my vertex. 3, negative 1, 4, negative 4. And it looks like the picture I had before. So it lets me see it opens down, but I really don't even need the picture. If my A value is negative, it's going to open down. That's just the way it is. And then my root, or my intercept, is the only place that I see where y equals 0. So this time there's only 1. My root's at 2. Okay? And I can get that from the chart, or I can get that from the picture. So it's not anything that's going to be terribly awful to kind of play with. Even if I had to plug the values in, no big deal. So I want to do one more. Then I will jump in and start helping with the homework here. Let's see, do I have an interesting one? Yes, letter D. We're going to skip over C and head down to D. So we're going to sketch this graph. Get that folded down a little better. So what do we got? Okay, my A value is 2. B? Nope, 8. My C ends up being 0 because I still have an X value there. So that's why my 8's going to be my B, but I don't have a just plain old number on the end. That's why my C ends up being 0. So I do negative B over 2 times A. That never changes. 2 times 2 is 4. And negative 8 over 4 is negative 2. Okay, as long as I get that X value, that's where I really got to take my time. Make sure that works out well for me. And then again, when I go to substitute, whenever I see an X that I get to, I'm going to take some parentheses. I'll plug that value in. See that X? Plug it in. And again, I can do that manually, or I can come back to the calculator and just type this in. So 2 times negative 2 squared plus 8 times 2. Wait. That's all. See, I'm not being careful. What did I do wrong? I did something, because I know the answer is not 24. What did I do wrong?
You didn't put the negative 8.
Yeah, I didn't put the negative there. And that kind of is going to make a big difference here. So again, we're kind of talking about this attention to detail here. And then I'm going and doing goofy stuff. Okay, let's see here. That's better. Because what would have happened if I didn't notice that right now, is that I very quickly would have found out when I got to the next part, A, it wasn't going to fit on my graph. And B, when I went to the calculator or started doing some of my others, I just started seeing, wait a minute, this isn't working out symmetrical for me. So now this time, I'm not going to go to the calculator, at least not the graphing part. I'm going to go ahead, I'll put my vertex in. And again, for my chart, you add 1, each value to the right, and you subtract 1 as you go each to the left. So you notice my chart kind of changes. But again, the cool thing is, the ones that are each 2 apart are going to be the same, and the ones that are each 1 from my vertex are going to be the same. So I want to find the easy values. I love 0. 0 is great, because when I plug it in, anything times 0 is 0. So even if I plugged this part into the calculator, I get 0 out, which tells me both of these are 0. Who wants to do all the work if I don't have to? So then I go to the other 2. I'm not thrilled about either one, but I'll just do this -1. And again, I'm taking the equation they gave me up here, and I'm going to plug this in. I can show you, because I haven't actually proven to you yet that this works. So let's say I did plug that -4 in, because I wasn't sure this 0 was right. So if I did that, okay, so here's my equation. I'm going to plug the -4 in. And let's see if Hardy's right or if he's blowing smoke here. Okay, so I still got 0 like I did on this one. Here, if I happen to plug in the -1 instead, so I'd plug this in. Oh, what'd I do this time? Oh. Now notice, like, well, it looks like a negative. Yeah, but I used the minus instead of the negative, so it gave me an issue. So -6. Now let's see, sort of like what Eric was mentioning, let's see that this really does work every time, and it does. I should get the same answer when I plug in -3. And I do. Okay, so if you want to double check them, you can, but it's just not something that you have to do. So -4 is 0, -3, -6. I already have my vertex. -1, 6, and 0, 0. So it got a little skinnier on me that time. But again, it folds up nicely down the middle. My roots are where y equals 0, or where I see it cross the x-axis. So there's 2 of them this time. And it opens up because my a value is positive. That's all of this in one big thing. And it's like, dang, but this is one of those that we're going to spend a few days on. So you're going to have some more time to get used to it and kind of play with it a little bit. So it's not one of those where we're in any kind of an emergency. So you're like, okay, so what's that got to do with what I have to do? Well, let me show you. What I'm going to have you do, I'm going to move this out of the way. Here's the actual homework sheet. Okay, this first page is like what we were just doing. Okay, you're going to find your x, you're going to find your vertex, but here's the difference on this one. When I go to find this out, so here I go, okay, my a value is -1, my b is -8, my c is -14. Just like I was doing before, I'm going to find my x equals first, which again is negative b, so the opposite of negative 8 this time, or you can just change the sign, over 2a. So the opposite of negative 8 would be 8. Yep, you can just put 8. So name the vertex. Okay, so we've got negative 4 for my x, just like I've been doing, nothing different. And then my y, every time I see x, I'm going to plug in a negative 4 in parentheses. Everything else, I'm copying the exact same way. Now that's kind of complex with all these negatives, so I'm going to get some help on this one. So I've got negative 4 squared minus 8 times negative 4. Lots of little detail things. So you're like, okay, so I've got my y. You're like, tell min or max. Well, how am I going to do that? Okay. Again, I can either make myself a chart, and I'm actually going to draw my chart even though I'm going to do it on the calculator. My vertex is going to go in the middle. And again, I add 1 as I go to the right, and I minus 1 as I go to the left. And again, if I don't want to plug all of this in, I don't have to. If I'm careful, I can just type this into the calculator, and I'm going to hit second graph because I want the table. Now, if I did things right, you're like, oh my gosh, those numbers, Hardy, they're so huge, I can't even get them on the screen. But remember, I want this vertex in the middle because look now, 1 and 1, negative 2 and negative 2, 7 and 7. I see the symmetry. So now I can just copy what I see for those values, and I can just swing them over here. So negative 6, negative 2, negative 5, negative 1, oops, negative 5, positive 1, hardy, 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 negative 4, 2, negative 3, 1, negative 2, negative 2. Min or max, if it moves, if it opens up, it's a minimum. If it opens down, it's a maximum. So this one has a maximum because it opens down. I don't even have to have a picture to be able to know that, though. As soon as I see a negative for my a value, okay, if my a value is, whoops, if my a value is negative, I'm going to get a max every time. If my a value is positive, I'm going to get a minimum, just because of the way that it opens. So what we're gonna end up doing is, there won't be new notes tomorrow. We're just gonna kind of pound away at some of these. So what I'd like you to do, even if you just have a regular calculator, because we saw how we can kind of just plug these in, if you could work on these first 4, just this front sheet, okay? Tomorrow we can kind of pound away more at some of the stuff on the inside and some of the ones on the back and just kind of get onto a roll. Tomorrow's going to be more of a work day that we've got doing these. But if you could just get a start on these first 4, even if it's just finding the vertex on them, would be awesome, okay? And then we'll get that set